Giving you an update on our projects here at the jwsolarusa in Minnesota. Some updates on the Volkswagen e-Golf lithium-ion batteries. So these are 2018s and these are Gen 2s, and just giving you the status of these batteries. They ran for 2.5 days. Sorry, 1.5 day, which is 1 hour, 1 day, 12 hours. Okay, so the batteries finally died this morning. I'll show you the time and all the specs about it. And now what we're doing right now, we go about charging back these batteries up and get them back in a full capacity and trying to drain them again and do another capacity test and see how the batteries can hold up pretty well for what we want to utilize them for. Stay tuned for this, and mind you guys, this one doesn't have any BMS hook up into this devices, these batteries at all. Okay, and we'll talk more about that later. Stay tuned. As the batteries died this morning, and I'm charging up these batteries right now. So what happened right now, you see the amperage fluctuating because it sits constantly at 56, 51, where it stays within the 50s. It's a huge battery bank to be charged by a small solar inverter, which is this guy here, Magnasign Magnum MMS 1012. So this is a big challenge for this guy to keep up charging those batteries, 4 batteries or 4 modules. As you see, I took the thing out, the kilowatt meter. So we are charging, and I'm not utilizing this bank right now, just want this system to charge up. You see what is happening here. Now the amperage came back up because the way you charge these batteries is a constant voltage, constant current. CV and CC. So they normally fluctuate back and forth. These batteries went all the way over 12.2 when the system, the fault light indicated right there. So guys, let me show you the fault that came up. So if we come here, fault history, inverter fault. This is the time when the battery went low. See, that battery went low at 0749. That would have made it completely 1 day, 11 hours. That was very close because around 8ish, we started the test. This is how you check things when you have this kind of machines. It records everything, knows everything. So let's check how many kilowatt hours we took from the batteries since we got them from Green Tech Auto. We don't even know if the batteries were charged. We know that they are of voltage. We don't know if the capacity or the state of charge, if they are 100% state of charge or not. I don't know what state of charge we got the batteries at, or we start the battery at, what state of charge. Now I have a kilowatt meter here, and you guys know what a kilowatt meter is. If you don't know, this is a instrument or device that's used to calculate or measure how much power you're taking from electricity or how much power you putting back in. And this device here, this particular one, the P3 and the Easy, this one you can program how much electricity costs, how much you buying electricity for, and it calculates how many kilowatt hours you've generated or you've taken out on this that passed through this device here. and go to any appliances. It's just like a shunt. Okay, it's like battery monitor, but this is a voltage, wattage, or amperage monitor. It can tell you everything. Electricity monitor. If you want to set up a solar system, you need one of these and have them plug into all your devices if you can afford it, or which some of them you can handle, because it only takes a certain capacity. You don't want it to go over, you can burn them out. So this is what it is. You can take up 1800 watts, passes through this guy. And this, the model number is a P4460.01 kilowatt easy. So this is the meter you need. You can program how much electricity, how much you pay for electricity, or how much you buy electricity on your state or at your state, or whatever generator, whatever you pull in power from. It measures everything. You need this guy if you want to set up a solar system and see how much kilowatt an hour or kilowatt hours you taking from the electricity for a day or week, or autonomy of your solar. You want to know if this freezer can run continuously for how many days before the battery is high, or how many wattage or kilowatt hours you taken. Or this is how you're able to use this to size your solar system from your daily consumption. So we plug this guy right here, and let's go back here and see how much power we took from the system, from the batteries. Okay, so this is the total. We pull about 4.21 kilowatt hours, and we ran for 30 hours 25 minutes. The good thing about this device, it saves everything. It saves the memory. If you're trying to get the other ones, I'll give you the comparison here. Here's a good comparison here. This is the other one. There are two different ones. This kind of beige color, off-white, and you see this, the screen around here. This one has like a gray scale around it. It's a kilowatt easy. This is just a kilowatt P3. They're all P3, but this one is kind of a little bit darker than this one. Is kind of like a beige. See, this kind of a little bit thicker, the color contrast. But if you look at the metals, almost similar. Set this guy here, almost similar to what I've shown you guys. And check this one out. Let me set them side by side. This is the one I took. You see the color? Now the actual color shows on the camera now. And look, you tell me what you see. See, the max current is 15 amps, okay? And 1800 on this one. 1800 watts on this one. And check this one out. This one here is 1875 kilovolts. Okay, you probably think this one is more, it can handle more power than this one. Is just 1800. But what happened, this one, I overloaded. This guy was beeping. When it packs the threshold, it will start beeping, and it will not stop. It's not gonna read above the threshold what this thing can handle. And what happened, it dies. Okay, and end up replacing it with this guy here. So this one works perfectly. It has more functionality, or more function, more features more than this one. This one stores memory. This one doesn't store any memory. Okay, when you unplug it or the power goes down, it goes down as well. So you lose everything you already saved or calculated for the past month, or whatever you're trying to figure out, you're not gonna have the answer for this anymore. You just lost it. But this guy can save all the memory. That's how I was able to show you guys. If you look at it now, it tells us that the total cost was 4 cents from these 4 point something kilowatt. So summertime is 10 cent electricity here in Minnesota. Wintertime, I think it's dropped to 9 cents, my area. So 4.21 kilowatts, I only pay about 30.25, because now I plug in at the time I started counting, or else it would say at 30.25. So at 4 cents. So from that 4 point something kilowatts here, I only pay 4 cents. Okay? Alright guys, because it's 10 cents a kilowatt. So I just want to show you guys what happened and how we went with the system. And the system is charging, and we see how long it's going to charge, how long it's going to take. This guy has been running since 9:30 this morning, and our local time here now in Minnesota is 12:30. It's 14:35 hours. That's 2:35. So from 9:30 to 2:35. So we've been charging for 5 hours. 5 hours now from 9:30 09:30 to 14:35 hours. So we started at 12.2 to bring us all the way up to 14.7, and we charge for 5 hours to get us here. And what happened right now, you see the transformer is getting hot and the air conditioner is running in the house, but this guy is really warm. We can check the transformer or the capacitor, because you can do that. This machine tells you everything. That's a good thing about Magnum, I like about it. So if we go temperatures here, you click on this, it's telling us that the battery sensor, which is not connected, that's not actual reading right there. We could have a temperature sensor. The transformer is sitting at 237 degrees Fahrenheit. That's very hot. Okay, and we're in the air conditioning. Remember, you're operating this in a remote area, somewhere that's really hot, so you're not gonna have much performance. That's why you've seen the amperage normally fluctuate, comes down and goes up again. This is the transistors. They're running 147, 149 degrees, 150, 150, 52 climbing Fahrenheit. There is no automatic generator to start temperatures, because you can have a temperature sensor if you want to. So just look at this, guys. It's very useful information right here. It tells you the revision of the system for the inverter, tell you for the remote, tell you for the automatic generator, supposed to tell you battery monitor key, the BMK, and supposed to tell you about the router if you have the router hook up into this. That's how amazing this little guy is. So look, I've shown you guys the model of this inverter. It reads it from there. So it tells you the inverter models, the MMS 1012. I mentioned that many times. There you go. Look at that. MMS 1012. Boy, the heat that is coming here out of this thing. Look at the transformer in there. There's a fan inside that thing. It's really hot. Look at that. You already seen the temperature is about 200 and some degrees. 200 plus. It tells you the fault history and set up a pin. I've never done this one. I never get into this. Maybe someone knows. I never read this part. I think just like if you want to set a pin so that nobody can do changes, just like the Outback, which is like 141, the password for Outback. For a lot of you guys who doesn't know, 141. You can enter into the remote so that nobody can monkey around it. That's a default. You can change it as well. I think that's the same thing with these guys, but I never set a password on this. And this guy I never read about this. I think it's an external control. Yeah, but it's not gonna give you anything. See, no external. I think it's external. That's what it is. And the load fault is gonna tell you everything about load fault. Select the load. Oh, sorry, load default. I'm sorry, I was looking the camera the other way. Over the camera, it's a load default. You can press and hold this. It's gonna bring all your settings back to default mode. Okay, so yep, so this is what it is. And the temperature again, let's go back into the transformer. 235 degrees Fahrenheit. That's very, very hot. Okay, you don't want to mess with that. So you see the amperage came back up, and it's charging 57 amps constantly when I started this thing earlier. But it's nice, getting hot. Air conditioner is blowing, or it's working in the house, but I think you just can't keep up with this device because it's far away from the air conditioning. The fan is running constantly. Just a fan that sits in between here, in the middle right there, sits vertical, blowing from here. And the interesting thing, I don't even see any holes at the front here where the fan can pick up any air from. But the front is really cold. This is where warm to the touch. This is where the electronics are, and mostly here's the transformer to cool the exhaust blowing out. So that's why you don't want anything to be placed on this direction, on this side here. Okay, so you have to keep this place really open. So for exhaust, blowing hot air out, it has a big metal underneath here. I don't know if you can see it in between here where the transformer sits, and it helps to dissipate heat as well. So that's why you guys understand now why I'm using all suspend your devices from the bottom. A lot of people like to install their system sitting flat on the wall, and it creates more heat as resistance build up. It's very, very hot down here. I can't put my finger there for a long time. I'm gonna be burnt. That's how hot it is. It's really hot, really, really hot. So these help to get the airflow through the machines. You know, you have a clearance. So I have a good clearance here, approximately very close to 1.5 inches, over an inch. So that's cool. Thanks for watching, guys. And this is just the updates for you guys on the batteries and how they charge with the electronics. And here is the battery bank. It's getting charged up. It's gonna take a while. Okay, like and subscribe. jwsolarusa, live from the command center in Minnesota. Love you guys all.